Dames en here, die akademiese prosesie sal binnekort inbeweeg. U word versoek om asseblief op te staan.
Bomma le bontate, molokoloko wa diruteri o tla tsena mo nakong e kopana. Le kgopelwa ho ema. Ladies and gentlemen, the academic procession will enter shortly. You're kindly requested to stand.
By the power vested in me, I hereby constitute this assembly as a legal congregation of the University of Pretoria. During this assembly, degrees with all the associated rights and privileges will be conferred on the candidates whose names appear in the program. Please take your seats. Ladies and gentlemen, we request you to join us in a silent prayer or meditation to give thanks for the achievements of our students. Thank you. Ladies and gentlemen, as the Vice-Chancellor and the Principal of the University of Pretoria, I extend a hearty word of welcome to you at this graduation ceremony this morning. I would like to welcome in specific the Dean of the Faculty, Professor Steyn, the Deputy Dean, Professor Meiner, is also present here on the platform. There are a few deputy deans in the faculty. That's the one deputy dean. And the second deputy dean is Professor van der Merwe, who is also on the platform party. The director for enrollment and student administration, who is Dr. Matega. Chairpersons of schools, heads of departments, directors, emeriti and honorary professors, and other lecturers and their spouses that are present here this morning. The representative of the Student Representative Council, Zakaya Madunjana, all persons on whom degrees will be conferred this morning, all spouses, parents, and other parties, as well as dignitaries of whom we may not be aware. And good morning to all of you. I now request the Dean to introduce to me the candidate for the Honorary Doctorate.
Mr. Vice-Chancellor and Principal, I have the honor of introducing to you Professor John Archibald Lennox Napier for the conferment of the degree Doctor of Engineering honoris causa. John Napier completed a bachelor's degree in chemical engineering at the University of Witwatersrand in 1967. After completing a master's degree in chemical engineering, he joined the Chamber of Mines Research Organization in 1971. He worked extensively on problems of operations research relating to coal mine production planning and gold mine planning. He completed a doctorate in 1980 at the University of the Witwatersrand with emphasis on the development of an econometric model of gold mine capital expenditure and the analysis of optimal cut-off grade selection policies. John subsequently assumed responsibility for coordinating research into the deep-level rock mass behavior of gold mine rock at Comro, which later became the CSIR Division of Mining Technology. John was appointed as a CSIR Fellow in 1997. While employed at the CSIR, he initiated several collaborative rock mass behavior research projects in Europe and the United States, in particular with the Department of Civil and Geoengineering at the University of Minnesota. John has been a visiting MTS professor in the Department of Civil Engineering on numerous occasions and has held an adjunct professorship in that department. His research interests include the development of numerical methods for the computational analysis of stress distributions near deep-level mine excavations and for the simulation of fracture propagation near excavation edges. He has also participated in developing computer models for the analysis of hydrofracturing and the simulation of geological dike propagation. He has held the position of extraordinary professor in the Department of Mining Engineering at the University of Pretoria since 2011. He has served as an advisor to several doctoral students. 4 of these doctoral students were awarded the prestigious Rocha Medal by the International Society for Rock Mechanics for the best doctoral thesis in this field in any particular year. This record is unmatched in any country. He was elected as an international member of the United States National Academy of Engineering in 2018. Election to this Academy of Engineering is among the highest professional distinctions accorded to an engineer. His lifelong interest in rock mechanics has been recognized by the South African National Institute of Rock Engineering, which has instituted the Napier Award in his honor. And in recognition of his achievements, John was also the first recipient of this award in 2019. The Napier Award is SANERE's most prestigious award and are typically awarded every 4 years in recognition of distinguished contributions to the field of rock engineering over many years. Mr. Vice-Chancellor and Principal, I request you to confer the Honorary Doctorate on the candidate.
I hereby confer the degree Doctor of Engineering honoris causa with all the rights and privileges on Professor John Archibald Lennox Napier. So I have the honour of requesting Professor John Archibald Lennox Napier to address the Assembly. Professor Napier.
Thank you. Chancellor, Vice-Chancellor and Principal, Council and Senate members, academic and support staff, students, parents and guests. It is a seminal honour today to receive this recognition of academic achievement bestowed on me by the University of Pretoria. It is inevitable that one will look back on previous experiences to acknowledge the conferment of an honorary degree. I myself was exceptionally fortunate to have been able to pursue a career in a mining research environment which provided the dual stimulus of developing practical computer programs for deep-level mine design calculations and being able at the same time to learn many aspects of engineering science and physics at the same time. I joined the Chamber of Mines research organization known as COMRO in 1971, in fact being a most unlikely choice of candidate with a degree in chemical engineering and absolutely no understanding of mining operations. My main interest at the time was in both computer coding and applied mathematics. I was assigned to the so-called coal mining laboratory headed by Miklos Shalaman, one of the famous pioneers of deep-level mine design in South Africa, using a particular mathematical approach, now termed the displacement discontinuity method, to analyze tabular layout stability. I reported initially to Dr. Frank Deist, who had developed one of the first digital computer codes using this technique in South Africa for deep-level mine stress calculations, and later to Dr. John Ryder, who also played a significant role in the formulation of early analog and numerical models for deep-level mine layouts. Most digital computer calculations at that time were carried out on mainframe computers with punch card reader interfaces for computer-run submissions and printed outputs on voluminous reams of paper. I worked initially for several years on developing simulation and planning computer systems at COMRO, including the attempt to model gold mine capital expenditure. However, in the late 1970s, early 80s, after serving my so-called apprenticeship in this form, COMRO was commissioned by the mining industry to develop a new version of Deist's original computer code that would be suitable to run on standalone mini-computers. These computers could be located and controlled directly at individual mine shaft offices. At the time, this represented a significant technological breakthrough. Dr. John Ryder and I were then given the task of developing a new compact computer code for this purpose. I did not realize that this was, in fact, the start of an adventure that would shape most of my future work in this field. Looking back, it is absolutely astounding to compare the performance of the pioneering mini-computers in those days, having core memory restrictions restricted to kilobytes and runtime speeds slower than primitive cell phones, to modern computer hardware and software capabilities. Machines now comprising processors, thousands of processors with the capability of performing at almost incomprehensible speeds of multiple petaflops. The recent development, though, of artificial intelligence and machine learning is equally extraordinary. I think one question that occurs very naturally to all of us is what cognizance do new generations of students and research practitioners establish for themselves in this apparently limitless universe of computer power and information availability? I can suggest that there are a few bedrock principles which could be considered for both vintage academics such as myself and for new participants in the generation of fresh innovations. This seems to me to revolve around 4 key propositions. The first one is to pose good technical questions for research goals that are to be achieved by using as much human academic insight as possible. Well-posed questions stimulate good science. The second proposition is to develop a framework to judge and question all proposed solutions and advances by applying critical human-based thinking, experience, insight, and judgment. The third proposition I suggest is that it's very important to involve multiple disciplines and viewpoints as far as possible in setting research goals and executing proposed research projects and programs. And fourthly, I feel that it's absolutely essential to maintain human interaction, debate, and training. And this is certainly a role which the universities can and do play. And it is also essential, obviously, for all of us to have personal encouragement of our colleagues, to students and colleagues. I don't think this can be overstated. Just in conclusion, I would like to acknowledge the warm friendships and interactions that I've had in the Department of Mining Engineering at the University of Pretoria. In particular, I'm privileged to have been associated with 2 extraordinary colleagues in this department at the university who have given me incalculable support and encouragement over the past years. These are Professor Ronnie Webber-Youngman, who took a huge leap of faith and who gave me an academic home at the University of Pretoria over the last few years. His incredibly generous spirit and big-hearted approach to encouraging good research cannot be overstated. I would like to acknowledge as well an enduring partnership with Professor Francois Malan, who extraordinarily arrived at my office at Comro many years ago as a student bursary holder. The assignment by the Chamber of Mines Bursary Office of a talented electronics student to a vacation job in the Strata Control Division at Comro is, to me, an enduring mystery. However, Professor Malan is now an internationally recognized leader in the field of rock mechanics practice and research, and is actively fostering a fresh thrust for responsible, safe, and innovative mining exploitation in South Africa. This is a key contribution to an indispensable industry which can shape the future prosperity and well-being of all people in South Africa. May I again express my profound thanks to the University of Pretoria for conferring this great honor on me today. Thank you.
I think we can give our honorary degree recipient another hand of applause. Thank you. I now request the Dean to introduce to me the candidates who present and whose names appear in the program, and to present that. Thank you.
Mr. Vice-Chancellor and Principal, the supervisors will now introduce the doctoral candidates.
Mr. Vice-Chancellor and Principal, I introduce to you Tsingai Betile, who has complied with the requirements of the degree Doctor of Philosophy, specializing in chemical engineering, with a thesis titled Exploring Dosage Forms for Release of a Lake Acid as a Mosquito Larvicide, prepared under my supervision as well as that of Professor Esram G. as co-supervisor. In this thesis, the candidate addressed the need for more sustainable interventions by developing biodegradable larvicidal delivery systems targeting mosquitoes in the aquatic larval stage. Malaria is a life-threatening mosquito-borne disease that remains a major global health challenge. Current malaria vector control strategies rely heavily on synthetic insecticides, raising concerns about environmental impact, toxicity, and diminishing effectiveness. Oleic acid was identified as a safe, naturally derived larvicide, and Zane, a biodegradable polymer, was evaluated as a carrier to enable its practical applications. The findings demonstrate that oleic acid can be effectively delivered in an emulsified form using Zane-based formulations, offering a promising approach to environmentally responsible mosquito control and supporting the development of sustainable malaria vector management strategies. Mr. Vice-Chancellor and Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all of associated rights and privileges on the candidate.
Mr. Vice-Chancellor and the Principal, I introduce to you Ubi Mpol Cynthia, who has complied with the requirement for the degree of Doctor of Philosophy, specializing in chemical engineering, with a thesis titled Coexisting Environmental, Metallic, and Organic Contaminants in the Aquatic Environment, Detection, Quantification, and Risk Assessment, prepared under my supervision, as well as Dr. Kuswayo as co-supervisor. In this thesis, the candidate explored the ecological and human health risk associated with the coexistence of contaminants of emerging concerns across multiple industrial effluent discharge points and Johannesburg Water's wastewater treatment plants, using multidisciplinary approaches of screening, identification, and quantification of CECs. The candidate established an integrated regulatory and monitoring framework to support risk-based environmental governance and enhanced protection of wastewater resources. The framework supports the formulation of targeted discharge controls, the prioritization of CECs, the re-evaluation of South African legislation regarding CECs, and the balancing of industrial pre-treatment and wastewater regulation in South Africa's rapid urbanization. The research aligns with the United Nations Sustainable Development Goals, SDGs. SDG goal number 6, clean water and sanitation, enabling monitoring and control of harmful pollutants. SDG goal number 3, good health and well-being, and SDG goal number 12, responsible consumption and production. Mr. First Chancellor and Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges onto the candidate.
Mr. Vice-Chancellor and Principal, I introduce to you Anja Sonnendekker, who has complied with the requirements for the degree Doctor of Philosophy, specialization in chemical engineering, with a thesis titled Development of PVDF-based protective coatings, applications for PVC, prepared under my supervision. In her thesis, the candidate investigated the development of PVDF protective coatings for PVC polyester-coated architectural textiles, addressing both material degradation and local manufacturing constraints. The work aimed to expand the local use of fluorine as part of the South African Fluorochemical Expansion Initiative. The research systematically evaluated coating formulation parameters, processing conditions, and substrate interactions to overcome the inherent rigidity and poor adhesion of PVDF-based protective coatings to PVC while preserving their exceptional ultraviolet resistance. Two viable strategies were established: plasticizer-modified PVDF coatings to enhance flexibility, and PVDF acrylic blend systems to improve adhesion without long-term migration risks. Accelerated weathering studies demonstrated significant improvements in the durability and service life of coated textiles. The work provided both fundamental insight into the PVDF phase behavior and particular coating design, delivering formulations compatible with existing dip-coated infrastructure. This research made an original contribution by enabling cost-effective, local manufacturable PVDF coatings that support sustainable material development and mineral beneficiation within the architectural textile industry. Mr. Vice-Chancellor and Principal, I request that you confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all of its associated rights and privileges on the candidate. Congratulations and well done.
Mr. Vice-Chancellor and Principal, I introduce to you Petrus Arnoldus Kraus, who has complied with the requirements for the degree Doctor of Philosophy, specializing in civil engineering, with a thesis entitled Centrifuge and Numerical Modeling of Triggers of Slope Failures, prepared under my supervision. In this thesis, Centrifuge and Numerical Modeling of Triggers of Slope Failure, the candidate investigated a range of triggers and mechanisms of slope failure in brittle soils, particularly focusing on undrained instability of loose slopes. The study assessed the likelihood of such instability being triggered under various conditions. Results showed that instability could not be induced unless the drained factor of safety approached unity, and that in such cases, undrained conditions were only observed locally. These findings suggest that the current industry approach requiring engineers to assume undrained conditions when assessing the stability of tailing slope regardless of trigger may be overly conservative and not supported by physical model tests. The conclusions hold despite concerted efforts to study slopes at highly contractive states exposed to various destabilizing triggers. The study provides important insights into the conditions under which drained versus undrained behavior governs the stability of tailing slopes and informs more economical tailing slope design practices. Mr. Vice-Chancellor and Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate.
Mr. Vice Principal, Mr. Vice Chancellor and Principal, I introduce to you Joseph Shumane Moema, who has complied with the requirements for the degree Doctor of Philosophy, specializing in metallurgical engineering with the thesis titled Effect of Heat Treatment on the Microstructure, Mechanical Properties, and Corrosion Behavior of Simulated Raw Bonded Aluminum Alloys 3003-4045 for heat exchangers, prepared under my supervision. In this thesis, the effect of heat treatment on the microstructure, mechanical properties, and corrosion behavior of simulated raw bonded aluminum alloys 3003, 4045 for heat exchangers. The candidate investigated the effect of excessive preheating times on the coarsening of dispersoids that degrade both the mechanical properties and corrosion resistance. To mitigate this, the optimization of the homogenization heat treatment times is critical for the final product quality. This research specifically examined the impact of isothermal soaking times on microstructures, mechanical properties, and corrosion resistance. Using theoretical and practical approaches, the study analyzed how preheating parameters influence the evolution and distribution of manganese-bearing dispersoids, which affect material performance. The main research contribution is the optimized homogenization heat treatment times for raw bonded aluminum alloys 3003, 4045 for optimal mechanical properties and corrosion resistance in tube stock materials for automotive heat exchangers. Mr. Vice Chancellor and Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges onto the candidate. Congratulations. Well done.
Mr. Vice-Chancellor and Principal, I introduce to you Zelda Wanakagane Sensu, who has complied with the requirements for the degree Doctor of Philosophy specializing in metallurgical engineering with a thesis titled In Situ Investigation of Austenite Ferrite Phases in Creep Strength Enhanced Ferritic Steels using neutron diffraction, prepared under my supervision. In this thesis, the candidate investigated high temperature phase transformations in 9% chromium ferritic steels used in power generation and petrochemical applications. Her research provides new insights into the evolution of ferrite, austenite, and delta ferrite at elevated temperatures and their influence on thermal expansion and microstructural stability. The study demonstrates significant variations in transformation temperatures and phase fractions between base and weld metals, highlighting the strong effect of chemical composition and thermal history. It further clarifies the role of residual austenite and martensite during reheating, showing how fresh austenite forms under different transformation conditions. The research addresses important gaps in understanding the high temperature behavior of creep strength enhanced ferritic steels and advances the application of in situ diffraction techniques for the accurate characterization of phase transformations over a wide temperature range. Mr. Vice-Chancellor and Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate.
Mr. Vice-Chancellor and Principal, I introduce to you Filani Lawrence Ngwenyama, who has complied with the requirements for the degree of Doctorate Philosophy specializing in mining engineering, with a thesis titled The Development of an Integrated Through-the-Air and Earth Communication System for Enhanced Real-Time Tracking and Post-Accident Rescue in Underground Mines, prepared under my supervision, as well as Professor Raj Naidu as co-supervisor. In this thesis, the candidate developed an innovative proof of concept of an integrated through-the-air and earth communication system. This hybrid system uses an adaptive decode and forward dual-mode channel. Real-time tracking data is transmitted via a through-the-air link under normal conditions. If the through-the-air link fails, transmission is automatically rerouted via through-earth link. Underground signal propagation simulations were conducted using an integrated modeling approach under non-line of sight and severe multipath conditions. An electrically small loop antenna was designed and optimized through modeling and simulating various antenna configurations and environmental conditions. It is anticipated that this system will form the backbone of the infrastructure for the modernizing underground mines and reducing missing person fatalities. Future studies will focus on developing a prototype of the proof of concept and testing it underground. Mr. Vice-Chancellor and Principal, I request you to confer the degree on the candidate.
I hereby confer the degree Doctor of Philosophy with all its associated rights and privileges on the candidate.
Mr. Vice-Chancellor and Principal, the following candidates have complied with all the requirements for the degree Master of Engineering specializing in Chemical Engineering. Peace Azeh, with distinction. My apologies. Kyla Kleinans, with distinction. Kayla Millard, with distinction. Arinao Munchu. Nolundi Ndwandwa, with distinction. Siyabonga Nkosi, with distinction. Laratu Tau, with distinction. Mr. Vice-Chancellor and Principal, the following candidates have complied with all the requirements for the degree Master of Engineering specializing in Geotechnical Engineering. Yaku Swanepoel. Mr. Vice-Chancellor and Principal, the following candidates have complied with all the requirements for the degree Master of Engineering specializing in Structural Engineering. Benedict Bull, with distinction. Owen De Lange, with distinction. Lerato Mahole with distinction. Damiano Teixeira with distinction. Mr. Vice-Chancellor and Principal, the following candidates have complied with all the requirements for the degree Master of Engineering, specializing in Transportation Engineering. Wasim Khan. Mr. Vice-Chancellor and Principal, the following candidates have complied with all the requirements for the degree Master of Engineering, specializing in Water Resources Engineering. Lucy Neiflis. Marita Pretorius. Joshua Spooner. Mr. Vice-Chancellor and Principal, the following candidates have complied with all the requirements for the degree Master of Science in Applied Science, specializing in mining. Willem Tron. Mr. Vice-Chancellor and Principal, the following candidates have complied with all the requirements for the degree Bachelor of Engineering Honours, specializing in Chemical Engineering. Khobudi Chepape. Nokwazi Mashlango. Mr. Vice-Chancellor and Principal, the following candidates have complied with all the requirements for the degree Bachelor of Engineering Honours, specializing in Control Engineering. Tamsanka Kujwayo. Mr. Vice-Chancellor and Principal, the following candidates have complied with all the requirements for the degree Bachelor of Engineering Honours, specializing in Environmental Engineering. Charity Chauke. Harold Grant. Jacques Minnaar. Mutsireletsi Pundulu with distinction. Mr. Vice-Chancellor and Principal, the following candidates have complied with all the requirements for the degree Bachelor of Engineering Honours, specializing in Geotechnical Engineering. Marilee Brink. Carlito Cosa. Andri Gubede. Tanaka Kamuriwo. Felix Manke. Cameron McCaw. Kashif Moodley. Devin Muller. Johan Pieterse. Sylvia Pristula. Ruan Reineke. Mr. Vice-Chancellor and Principal, the following candidates have complied with all the requirements for the degree Bachelor of Engineering Honours, specializing in metallurgical engineering. Nokulunga Shlope. Lindokuhle Linda. Sorry. Molalu Manwata. Paris Matabata. Mr. Vice-Chancellor and Principal, the following candidates have complied with all the requirements for the degree Bachelor of Engineering Honours, specializing in mining engineering. Shlompu Sekati with distinction. Mr. Vice-Chancellor and Principal, the following candidates have complied with all the requirements for the degree Bachelor of Engineering Honours, specializing in structural engineering. Yolandi Bezuidenhout. Tinutenda Dliwayo. Joandre Herselman. Marian Niwaireza. Prosper Oketwengu with distinction. Gobochepu Telekua. Mr. Vice-Chancellor and Principal, the following candidates have complied with all the requirements for the degree Bachelor of Engineering Honours, specializing in transportation engineering. Emil Asari with distinction. Kondwani Mangoni. Solomon Musoki with distinction. Raylene Nijker. Sipu Skosana. Robert Wyden. Mr. Vice-Chancellor and Principal, the following candidates have complied with all the requirements for the degree Bachelor of Engineering Honours, specializing in Water Resources Engineering. Belusi Mpofu. Prince Mushanya. Nathan Samuels. Mr. Vice-Chancellor and Principal, the following candidates have complied with all the requirements for the degree Bachelor of Engineering Honours, specializing in Water Utilization Engineering. Sipusonke Kanje with distinction. Pumalele Mota. Courage Mureri. Asipe Nketani with distinction. Mr. Vice-Chancellor and Principal, the following candidates have complied with all the requirements for the degree Bachelor of Science Honours in Applied Science, specializing in Chemical Technology. Ebunolowa Adetula with distinction. Adonai Abtamariam with distinction. Walile Jele. Zutani Kanjile with distinction. Notandu Masuku. Nkipiteni Mbeti. Vuyishwa Nyoko. Menenhle Shandu. Sichle Simalani with distinction. Mr. Vice-Chancellor and Principal, the following candidates have complied with all the requirements for the degree Bachelor of Engineering Honours, specializing in Environmental Technology. Sukwele Kobjana with distinction. Posaletsu Mabote. Letwin Mafukitse. Tapelo Mampolo. Seroli Matlo. Lesegu Molekwa with distinction. Vuyowetu Mvambi. Mapula Semenya with distinction. Mr. Vice-Chancellor and Principal, the following candidates have complied with all the requirements for the degree Bachelor of Science Honours in Applied Science, specializing in metallurgy. Josiah Koza. Mosima Maja. Jonathana Mkanzi. Fikile Mkabela. Johannes Mohoye. Tabisu Pakalasi. Mr. Vice-Chancellor and Principal, the following candidates have complied with all the requirements for the degree Bachelor of Science Honours in Applied Science, specializing in water utilization. Tubelichle Blozi with distinction. Velile Chili. Nalishwa Dlamini. Nomtandazu Kusi. Lekwani Lechodi. Machemi Mabaso. Bongani Makechle. Florence Manyama. Berlinda Matlala. Mapaseka Mawasha. Ntabiseng Mija. Bongani Mshlambo. Tulani Ngomazulu. Remoletile Mokoloane. Lucy Mutswai with distinction. Marian Msiza. Moketi Nopach. Getja Selepe. Mikateku Silenge. Mr. Vice-Chancellor and Principal, the following candidates have complied with all the requirements for the degree Bachelor of Engineering in Chemical Engineering. Noaim Ahmed with distinction. Malar Abte. Marco Arnold. David Bender. Caitlin Breitenbach. Rikus Burger with distinction. Obilwe Chiluane. Divan Solier with distinction. Stefan Coetzee. Orlando da Souza Melim with distinction. Gian de Beer. Mandisu Dlamini. Zahari Edwards with distinction. Athanasios Georgiolakis. Raylan Govender with distinction. Hendrik Greef with distinction. He also receives the award of the Vice Chancellor and Principal. We will get to that at the end of the ceremony. The South African Institution of Chemical Engineers Medal for the best final year student in chemical engineering. The PPS Prize for the best student in chemical engineering practice. The Proconics Holdings Prize for the best final year design project, and the Medal of the Engineering Council of South Africa for the best student in the final year in the School of Engineering. Well done. Jared Groenewald. Kurt Hout. Jacques Herselman with distinction. Mielani Shlongwani. Tabu Shlope. Marcus Hichu. Evan Jacobs. Ketumetse Kuloti. Tafadzwa Kungwengwe. Albert Leroux. Rifiwu Mashlole. William Mashegu with distinction. Ryan Maxwell with distinction. Herman Meyer. Nomkele Mishlanga. Khomotsu Mohafe. Joshua Moodley. Tebogo Morake. Sandile Mtambo. Livowani Mulawutsi. Nolwazi Mkube with distinction. Henku Neetling. Jude Nong. Tyron Pirumasami. Kostaki Potgieter. Christian Pretorius. Ruan Rabets with distinction. Simone Raubenheimer. Joshua Schreiber. Matopi Shongwe. Lazan Strydom. Divan Swart. Tamsin van den Berg with distinction. Damien van Tonder. Samkelo Vella. Ines Venter. Hendrik Viljoen. Stefanus Foster. John Williams. Mr. Vice-Chancellor and Principal, the following candidates have complied with all the requirements for the degree Bachelor of Engineering in Civil Engineering. Irsa Akmal, she also receives the Jones and Wagner Prize for the best final year research project in the field of specialization, geotechnical engineering. Well done. Brandon Alfonso. Nicholas Allen with distinction. He also receives the South African Institute for Steel Construction Prize for the best student in structural steel. Well done. Stefan Badenhorst. Roan Besuidenhout. Sky Boy. Well done. Samantha Bosch. Larissa Brits. Sebastian Casal Gallego. Chidu Chikomba. Salmon Sillier with distinction. He also receives the South African Institute for Steel Construction Prize for the best student in structural steel and the Zutari D.W. de Vos Prize for the best final year student in civil engineering. Well done. Ryan Cornelius. Christopher Cronje. Bulumko Dawedi. Sayan Dayaram with distinction. She also receives the AfriSam Prize for the best final year research project in the field of specialization, material engineering. Well done. Zandile Dwane. Amiku Eibers with distinction. He also receives the J.C. Wagner Prize for the best student in civil environmental management. Well done. David Galbraith. Shravan Goli. Apile Khadebe. Lloyd Hansmeyer with distinction. Carla Hendricks. Gunther Herold. Arno Heidenrich. Kom. Toloanimi Ikotun. Elago Ilonga. Brandon Janse van Rensburg. Samuel Kalonda. Shekina Kaninda. Hana Lawani. Pihaha Madibana. Lloyd McGee. Nell Mashlangu. Lasiba Marakalala. Khomotsu Maroja. Tomo Matabane. Khalaborua Matabata. Ayanda Mavuso. Simpiwe Mbukazi. Lungile Mkize. Chepu Mukwele. Heinrich Mollermann. Kotsu Molloy. Massimo Mordini. Kakhishu Moroke. Mduduzi Moyo. Zetule Msiza. Sianda Mchali. Charlize Nell. Hans Nkonde. Muziwandile Nkosi. Ikanyeng Pashani. Trinity Pokoje. Majoran Pillay. I'm glad. Well done. Quentin Potgieter. Regan Pramraj. Kara Prinsloo. Johannes Prinsloo. Heinrich Rademan. Mashwini Ramabua. Kikeletsu Ramanamane. Twelupele Ramano. Tushar Ramdani. Andrea Ramsay. Keegan Redlinghuis with distinction. He also receives the Infrastructure Planning Prize for the best student in infrastructure planning. Christian Reder. Lesedi Rikotsu. Jolene Ruizi. Kyle Sathia. He also receives the Transnet Freight Rail Prize for the best final year research project in the field of specialization, railway engineering. Well done. Tavish Sibran Ramtol. Frank Sibanda. Kylan Smith. Divan Smuts. Lorenzo Southern. Benjamin Teeling. Vian van Deventer. Peter Virtue. Christoph Werner. Tonderai Zimvumi. Mr. Vice-Chancellor and Principal, the following candidates have complied with all the requirements for the degree Bachelor of Engineering in Metallurgical Engineering. Willem Geerkens. Christian Gill with distinction. He also receives the following awards: South African Iron and Steel Institute Prize for the Best Finalist in Metallurgical Engineering over 4 years of study, the Department of Material Science and Metallurgical Engineering Project Prize for the Best Final Year Project in Metallurgical Engineering, and the South African Institute of Mining and Metallurgy Achievement Award for the Best Student in the Final Year in Metallurgical Engineering. Well done. Muheen Hoosen, he also receives the Anglo-American Prize for the Best Final Year Student with the Best Final Year Project in the field of pyrometallurgy in the Department of Material Science and Metallurgical Engineering. Well done. Tandu Jele. Yaljune Kemp. Mahlatsi Langa. Kekaletsu Madibo. Nicolas Maripane. Uzumwaka Ozu. Michaela van Aert. Mr. Vice-Chancellor and Principal, the following candidates have complied with all the requirements for the degree Bachelor of Engineering in Mining Engineering. Beverly Shavalala, he also receives the Mine Ventilation Society of South Africa Prize for the student with the highest final mark in Mine Ventilation Engineering. Well done. Nompumelelo Funde. Christian Janse van Rensburg. He also receives the Medal and Prize of the UP Mining Alumni Society for the Best Student in Mine Design, the South African Institute of Mining and Metallurgical Achievement Award for the Best Student in the Final Year in Mining Engineering, and the South African National Institute of Rock Engineering Prize for the student with the highest final mark in Final Year Rock Engineering. Well done. Nkele Kadi. Dipu Maslakwana. Nomsa Matabula. Candice Mdaka. Sizwe Mkwanazi. Tumelo Ntesu.
I now request the Dean to introduce to me the candidate for the presentation of the award of Vice-Chancellor and Principal.
Mr. Vice-Chancellor and Principal, I have the honor to introduce to you Hendrik Jacobus Greef for the presentation of the award of the Vice-Chancellor and Principal. Hendrik Jacobus Greef complied with all the requirements for the Bachelor of Engineering in Chemical Engineering on 28 November 2025, and the degree was conferred with distinction. Hendrik Greef is acknowledged as the overall top achiever in the Faculty of Engineering, Built Environment and Information Technology for the year 2025. Mr. Vice-Chancellor and Principal, I request you to present the candidate with the award of the Vice-Chancellor and Principal.
I hereby present Hendrik Jacobus Greef with the award of the Vice-Chancellor and Principal. Right, I think we should first give the Dean a hand of applause. I think he has done very well with the notice. And then I would like us, as the audience and the platform party, to congratulate our graduates for their achievements. Well done. And I'm gonna ask the graduates just to stand up. Try to make eye contact with your family members wherever they sit, and shout out their appreciation for what they've done. Right, thank you. I don't want you to sit. Because there's some more appreciations that you have to shout out. So on the platform, we have the academics. In fact, not all of them are here that have taught you in your different programs, but they are really the proxies of the academic staff of the Faculty of Engineering, the Built Environment and IT. And the academic staff is often been seen as the brain trust of the university. it's the academic staff that help us to ensure that we not only have good quality programs that we offer, and that we not only produce good quality graduates for our economy, not only in South Africa, but on the continent and globally, but that they're also providing and developing and contributing to new knowledge in the form of research, but more so also new knowledge that can make a contribution in the lives of people, in the lives of companies, of industry, and the private sector. And I would like you to put your hands together for the academic staff that have helped you, have contributed to bring you here today, and hopefully have equipped you in partnership with you with enough technical knowledge for you also to make a massive contribution to society. Now you can put your hands together for academic staff. Okay. But as you know, the university doesn't always consist of academic staff. We've got a total number of 6,500 staff at the university over our 7 campuses. And the last proportion of those staff are staff that we call professional staff, support staff, administrative staff. And they are the staff that you don't often see necessarily at the forefront is when we talk about the academic project at the university. But they are the staff that's often on the periphery, but without that, your academic project, your academic qualification would not have been possible. They are the staff in the registration offices, in the graduation offices, in the student accommodation, in the facilities management to make sure that our campuses are neat and we can welcome your parents, your friends, visitors. And they are the staff that I would like you to put your hands together. And now you can be seated. Thank you. So we've now come to the end of our proceedings. Before we close, I wish to invite all present for liquid refreshments afterwards in the marquee in front of the Rembrandt Hall. You are requested to stand for the singing of the national anthem and to remain standing until the assembly has been dissolved and the academic procession has left the auditorium. The words of the national anthem will appear on the screens. Can I ask you to please rise?
Oh
By the powers vested in me, I hereby dissolve this assembly of the University of Pretoria.
The graduates have spoken. Let's give them up the one. Graduates, I'll go on and more. The graduates. Sure. I'm that and take it.